Good evening, everybody. Good evening, Mark in particular, and welcome to the Republic of South Yorkshire. I have a short introduction, but before I read the paragraph about Mark, anybody looks on our website, and you can open this up with the link there and print it off, and it tells you most of the projects that Mark is involved with, and a short paragraph about himself. So I hope you'll find it interesting. So, Mark, an astrophysicist. He works in both theoretical and observational projects related to directly imaging extrasolar planetary system. He's also the Citizen Science Officer for NASA's Science Mission Directorate, helping look after 22 NASA citizen science projects, connecting more than 1 million volunteer scientists around the world. And if you look below on the internet, you can see the specific scientific projects that he's interested in. So please welcome, in a traditional Mexborough and Swinton Astronomical Society way, Marc Kuchner.
Yeah.
Thank you.
Splendid, splendid.
Okay, so you are now spotlit, Mark.
My goodness. Thank you for having me. I feel almost like I know this group already because Peter sent so many pictures. Peter sent, he made this blog post about his presentations to the group. I've seen pictures of you. I've heard my other colleagues at Backyard Worlds Planet 9, Disc Detective, tell me how much they've enjoyed chatting with you, and I've been looking forward to it.
So very kind.
I understand that you've heard a lot from my colleagues already about citizen science projects. Peter asked me to talk a little bit about Disc Detective. I also, because I'm the citizen science officer for NASA, I also have to take this opportunity to show off just a little bit about NASA citizen science in general. I'm going to try to share my screen and see if I can get that working. No.
Okay, I've got your desktop.
How's that?
And yes, that's lovely.
You see me looking so handsome there?
I couldn't possibly comment.
No, you couldn't. All right. So, assuming everyone can see this, there's me looking cheerful. And as I was saying, I know that you already are very keen on citizen science, amateur astronomy. By the way, we consider amateur astronomy to be citizen science. It kind of comes under our purview. And so I also am lucky enough to have the chance to work on raising the profile of amateur astronomy and the connection between amateur astronomy and NASA science while I'm in this position. So I want to start by thanking you for the science that you're already doing and let you know that NASA is paying attention and we care and we're grateful. So keep up the good work and tell me more about it. I hope you'll tell me more about other things that are going on in your society at the end of my talk. So as I was saying, you're going to have to endure a little bit of bragging about NASA citizen science in general. I'll talk about some astronomy projects in particular, including Disc Detective. And then I was hoping to ask for your opinions on a conference that I'm planning sort of in the back of my mind that would bring together amateur astronomers and NASA scientists, as I was saying. Okay, here we go. NASA citizen science projects have discovered 400,000 Martian seasonal fans, 54,000 circumstellar disks, 18,000 mosquito breeding sites, 1,600 brown dwarfs, 8 interstellar dust grains, 4 new meteorites, and a new kind of aurora. And I'd like to say that you're going to help me write the next verse. The projects do all kinds of things besides discover stuff. They save lives, like Landslide Reporter asked people to submit observations of landslides, which obviously kill people and destroy property. So we're working on new models of how landslides begin that are informed by the citizen science reports we get. I also want to mention Mosquito Habitat Mapper. And if you like to be free of malaria and dengue, then this is a good project for you. People go and look for places where mosquito larvae could grow, and if they're really into it, they can even take pictures and try to identify the larvae and what kind of mosquito they are. And one of the things I like to point out to all of my colleagues is that citizen science projects, the best stuff that's come out of our programs is stuff that we didn't expect. So all of these discoveries here were surprises. The science teams didn't plan for them. The magic of working with citizen scientists produced them. Either the idea to look for these things was suggested by the citizen scientists themselves, or something appeared in the data that nobody knew to expect. Anyway, NASA citizen science projects have discovered most of the long-period extrasolar planets. Most of the known comets were discovered by amateurs, NASA amateurs. The oldest white dwarf with a disk, you probably heard about that in a Backyard Worlds talk. The Peter Pan disks, I'll talk more about those later. The Dipper star phenomenon, the yellow balls, star-forming regions. Notice that cemeteries with flower vases in Peru were key to spreading Zika virus, and discovered the Steve phenomenon. So all those things surprise us. One of the benefits of working on citizen science is the surprises. Altogether, I've tracked 138 NASA citizen scientists who've become named co-authors on scientific papers because of their work. And that doesn't count all the various other ways that citizen scientists have contributed to the scientific literature, such as conference proceedings, posters, and so on. I also always have to tell my colleagues that citizen science papers are better cited than typical papers. So here are two studies of citation of citizen science papers. The one on the left compares projects that are limited to space science, citizen science projects. The purple lines are citations for citizen science papers, and the other curves that you see on the other dashed line and dotted line are samples of non-citizen science papers. And look, purple is higher. On the right, this interesting study compares publications from citizen science projects to publications from other projects that are based on the same data. So you can see that the citation rates are higher for the citizen science project using the same data. Wow. Who are NASA citizen scientists? They are Peter. Thank you, Peter. There's supposed to be like a crowd reaction to that. Can you guys hear me?
We can, but we're being very British and very polite.
Okay. Okay, well, so I'll keep going, but I want to encourage you to interrupt me and ask questions, or tell me if I'm telling you stuff that you already know.
That's okay. We will if we come up with anything interesting to say, Mark.
Okay, excellent. So a little bit more history about how NASA got into this. The Space Act Agreement, which created NASA, says that we're supposed to disseminate information, but that was back when there weren't so many tools for collaborating. The amazing thing that's happened in the last 15 years, I don't have to tell you, all is that we have the internet and we can all engage in these massive online collaborations and work together. And NASA helped pioneer that with clickworkers in about 2000, and where they put up data on craters on the moon and on Mars, and asked people to help count them. And the volunteers who contributed to counting craters did a super job. Their crater counts were every bit as accurate as the professional scientists. Unfortunately, it turns out that professional scientists all disagreed horribly over the counting of the craters. But nonetheless, it started to get people excited about the power of online citizen science, and that was a NASA Ames project. Then later, Andrew Westphal at Berkeley started a project called Stardust at Home. And I think he was inspired. I asked him, what inspired him to do this project? And he mentioned a couple things. He mentioned that his father, Jim Westphal, who was director of Palomar Observatory, was a keen amateur astronomer. And he also mentioned that he was inspired by the Super Kamiokande experiment, where the goal is to detect very rare particles. And in order to detect these very rare particles, what they do is, instead of having just one detector, they have as many as they could possibly build. And it doesn't matter in that case if all of your detectors are, if some of your detectors aren't perfect. You'll still, the more you have, the better, the more science you'll accomplish. And so he thought, well, what if I open up science to members of the public? I'd like to detect this different kind of particle that comes from interstellar space. What if I show my laboratory images to members of the public? And if a few of them aren't trained all that well, then that's okay. The more people I can involve in the project, the more discoveries I make. And since no one has found any single interstellar dust grains before in a sample return mission, the more I discover, the better. So he launched Stardust at Home, and indeed they've discovered 8 interstellar dust grains. Those are the only samples of interstellar material that we have. We have, let me repeat that again. Interstellar material, right? So this isn't material that's come from another planet. It hasn't come from the atmosphere. It hasn't come from Jupiter, Mars, the asteroid belt. It came from somewhere beyond the solar system. We have exactly 8 pieces of stuff in our hands that we can say came from beyond the solar system, and they're all found through the Stardust at Home project. This project, of course, went on to inspire Zooniverse, and Zooniverse is the platform that hosts Backyard Worlds Planet 9, Disk Detective, and our new Planet Patrol project that just launched last week. Oh, this is out of date. We have 22 active NASA-funded citizen science projects. They're all at science.nasa.gov/citizenscience. I'm going to skip ahead and tell you more stuff that I think you'll be keen on. Aurora Source project. I mentioned Steve. Raise your hand if you've heard of Steve. Actually, don't raise your hand because I can't see you anyway. Would you like to hear about Steve?
Yes, please.
Excellent. Steve is the nickname for a discovery from our Aurora Source project. Aurora Source Citizen Science project asks people to, there are 2 ways you can participate. You can either go on Twitter and help, or social media in general, and help track tweets that are about the Aurora. And that's important because some people who have kids who are named Aurora, and they tweet about them, and we love your kids, but we don't really need that info for our science project. So we need humans to vet tweets, and we also ask people to go out and take pictures of the Aurora. And you see here a diagram that shows a model, which is a prediction for where the Aurora is supposed to be, and then it's compared to information from Twitter and from the aurora photographing community about what people actually saw. And so the Aurora Source project was designed to sort of test these models and compare, are we predicting the actual location of the aurora? If we do, then it probably means we understand how the Earth's magnetosphere interacts with the solar wind, which is important because it'll tell us when we're going to have massive solar storms, which of course can cause big power outages and communication outages. And if we don't, we better go back to the drawing board. So sounds like a good concept, but of course the surprise is that there's a new kind of aurora. I think I have a picture of it. And it's this little purple stripe here, shown in the picture. And it was discovered by the aurora observers from Aurora Source. They were taking pictures of the aurora, and they said, hey, what's this little purple wiggly thing? And this was just published a couple years ago. I'm showing you this quote here to illustrate how unusual it is to discover something new in the aurora, because you can observe the aurora with the naked eye, and humans have been doing it for a long time. So Larry Lyons says, finding something that you can identify as a new structure in the aurora is relatively unusual. The last major thing was poleward boundary intensification, and you can find that name used back over 20 years ago. So you get a new aurora discovery about once every few decades, and Aurora Source got one. Steve now is alive and well on Twitter. Steve, by the way, was originally named just Steve by the citizen scientists who discovered it. But since then, it was converted to an acronym, actually a backronym, right? So now Steve stands for Strong Thermal Emission Velocity Enhancement. Did I mention that most of the known comets were discovered by NASA citizen scientists? Well, they discovered these projects through a project called the Sun Grazer Project. And the incredible thing, besides the fact that we discovered more than half of the known comets, the incredible thing to me about this project is that it didn't start with the scientists going and saying, hey, I need some help with this, come help me out. It started with members of the public going to NASA archives and spotting interesting things and then pestering scientists to help tell them what was going on. And they emailed Carl Badams over and over again. And eventually he got frustrated with having to reply to so many emails, and he set up a web page saying, hey, if you think you found a comet, go do this, check this out, and it's probably not a comet, but go away and do these 12 things, and if you still think it's a comet, then get back to me. And that turned into the Sun Grazer Project, because people took his advice, they followed through his steps, and they kept discovering comets. It's still going on. They just reported their 4,000th comet. Got to update this slide too. This animation illustrates the discoveries from the Project Sun Grazer. You can tell, of course, which ones are planets. There are those comets flying in. Every single one of those green, red, blue, yellow, zipping things is a comet that was discovered. And you can see an interesting thing, they come in these groups, right? So probably what's going on is there was some larger body that fragmented into pieces. See, the red objects are the Kreutz family. This whole family of comets was discovered by the Sun Grazer Project. It's probably one comet that shattered or was tidally shredded by close encounter with the sun. It's a whole family of comets. The International Astronomical Search Collaboration is a NASA citizen science project that was recently in the news because a pair of schoolgirls in India helped discover a near-Earth asteroid. You may have seen that in the news. This is an interesting project. It's all about discovering near-Earth asteroids. And It's really been most effective working with groups from schools. They also work with groups from different societies. If you folks were interested, you could email them, and they would, I'm sure, be delighted to have your help. They'd send you some data from the Pan-STARRS project and some astronomical software. You may have that already, but they'd send you some software and coach you through the process of searching for near-Earth asteroids. And anyway, this project's been news lately. They've discovered 47 new asteroids, and there's that email address if you're interested in joining the campaign.
Будущие астрономы из Московского дворца пионеров продолжают изучать найденный ими же астероид.
Вот так он пролетел, он улетел за орбиту Марса, и его орбита примерно в Солнечной системе выглядит примерно вот так.
Ищут небесные тела по снимкам, которые делает американский телескоп, установленный на Гавайях. Ученые США...
How's your Russian? Mine is not very good. But the point of showing you that was to show yet another group that's very proud that they discovered some near-Earth asteroids, helped discover asteroids through the International Astronomical Search Collaboration Project. Okay, now we're at Disk Detective. So Disk Detective was how I got started in citizen science. So I had a personal crisis, I guess about a decade ago, where I was trying to figure out what brings meaning to my life. And I felt very lucky to have a chance to be a professional astronomer, but I was frustrated that the work I was doing was shared by a small community, by a small group of people. And so I began on a project for myself to try to understand how, why we don't have more people around the world doing science with us, and what we can do to share the process of science. And I stumbled upon Zooniverse and citizen science as a promising way to do that. I like that citizen science does more than just share science results. It also shares the roller coaster ride. Peter can tell you about the ups and downs of this process as well as I can. It's an experience. It's a moving, life-altering drug, and this Disk Detector project was my first sniff of that drug, I have to say. So I started this project back in 2014, put it on Zooniverse, and recently the project's being relaunched by Steven Silverberg. Steven came on as my graduate student back in 2016, and he's since taken over the project. But I'll tell you a little bit about what we discovered over the years and why it was so addictive. So in this project, we're looking at data from NASA's WISE mission. Wow, it's a gift that keeps on giving. It's a mission that has observed, at this point, we've counted over 2 billion sources. So it brings us one of those delicious, splendid big data problems that we often have at NASA, which is that 2 billion objects is just too many for one person alone to handle. And what you do is you take your best computer coders and your best grad students, and you tell them, oh, okay, take your computer and try to make your way through this big data set. And the computer does a great job, does a fantastic job. It gets the answer 99% right. But 99%, but that leaves 1% of a billion objects that the computer couldn't handle. Right? So we have to go back and take those 10 million objects, which are the most interesting ones, because we didn't know what to do with them. So that's where the science is by definition. Take those most interesting objects, and we ask members of the public to help us make sense of them. So here's what the most fertile direction has been for Disk Detective. So stars form in special parts of the sky, right? And these young stars are born together in these groups, and then they start spreading out over time. So if you want to find young stars, and if you want to learn about the timeline for how stars evolve and how planetary systems evolve, you want to track these groups of young stars, which are sometimes called young moving groups or young associations. So these groups provide our timeline for understanding planet formation. It's very hard to figure out how old a star is. As you folks, I'm sure, are well aware, they don't come with labels on them telling us how old they are. We have to go out and use our sleuthing skills and try to understand the ages of stars. And so if we can spot a group of stars that all formed at the same time, then we can use our models to try to infer the common age for the group, and that's way easier than trying to infer the age of one particular isolated star. So the result is that there are all these groups. There is a growing list of them. There are maybe 60 of them or so known by now, of stars where we've got dates for them. We know how old all the stars are. So if we can see a phenomenon that is different from one group to the next, we can make a timeline for what's going on there. So for example, if we look at young groups and we see that all of those stars have disks around them, and we look at older groups and we see that the disks are gone, then we can figure out how long the disks live for. So how long we have that circumstellar material around to form planets. So Disk Detective has the advantage of being an all-sky survey with lots of helpers, lots of data, and it's a very powerful way to find these disks around young stars that are in moving groups, that show us the sequence, that show us how planets form. So Disk Detective made the remarkable discovery that, remember how I was saying how these disks can fade out? You might look at a group of stars in an older system and find that they don't have disks. Well, typically the stars tend to fade out around 5 or 10 million years. Disk Detective discovered a group of disks that persists at much older ages, almost at 50 million years age. So these are the oldest known protoplanetary disks. They're all around relatively late type stars, relatively low mass stars, which probably makes sense because those stars tend to evolve more slowly in other ways. They have less mass. They are less likely located near massive stars that are going to clear out the disks through external radiation. But the thing is, nobody had found these objects before, and the whole community is planning all of their planet formation models around the assumption that there is less than 10 million years to form a planet like Jupiter. And guess what? It's not 10 million years. Sometimes you have up to 15 million years, maybe even longer. Maybe we'll find even older examples of these things. And of course, we owe our name to Jim Barry's book, Peter Pan, who, of course, is the boy who won't grow up. Just like these disks, they won't grow up. So, encouraged by that discovery of Peter Pan disks, we've embarked now on a bunch of other studies using Disk Detective. One is that we took the results from the first incarnation of the project and we combined them with a convolutional neural network. And the network is not as good as people, but since we were able to train it on the results provided by all the more than 30,000 citizen scientists who participated, produced some useful results and generated a longer list of candidates than we had to start with. So combining the neural network and the humans, we've collected a list of about 54,000 excellent disk candidates all around the sky. And we're working now on following those up. One way that we're following up is using a new virtual reality tool. So this tool shows you the locations of, that's about 6 million stars that have recently been measured by the Gaia mission. And through this tool, we're flying around through these stars in virtual reality, and we can also evolve them forward and backward in time. It's just going to repeat, but and then we can add to these known stars. We can label them according to which ones are in our sample of disk detective disks, and we can compare them to the known moving groups. So now I'm going to show you. Those are 47 known young groups of stars that we flagged in our virtual reality simulations. And we can watch those move, and we can compare them to the new disk detective objects. So take a look at the orange dots, which are new stars with disks that we've discovered through disk detective. And ask yourself whether you think they belong with the Carina purple dots or the green Tuck-Hor dots, for example, as this goes by. The axes, by the way, that's the galactic coordinate system, XYZ coordinates. See those orange dots zipping by? Oh, now we have to catch up because the group is moving. It's evolving in time. What do you think? Tuck-Hor, Carina, or Columba, or not at all? I'm taking a poll. I'm checking to make sure you guys are following me.
None at all.
None at all. Okay, we have one vote for none at all. Anybody else?
Hard to tell from me.
Play it again.
I find it very difficult to see the colors.
Yeah, it's this is a good illustration of why we need virtual reality, because it's really hard to make sense of this on a flat screen. So I'll just tell you the answer, the conclusion that we came to, which is that we have a bunch of these, not all of them, but maybe 3/4 of them are reasonably closely associated with Columba and Carina, but not Tuck-Hor.
Mark, if you were
Yes.
doing this, or one of your collaborators were doing this, presumably they would perceive this in 3D. They would have a 3D.
Yes, they would. They would be wearing these goggles and looking at this in 3D. Exactly.
Right. Very fetching.
So one of the extensions I've started discussing with some colleagues at Rochester Institute of Technology is if we can, how far can we take this? Is it possible that for a future version of Disk Detective, we'll just do the whole thing in virtual reality to begin with? So I don't have the answer to that yet, but we've started investigating that. Wouldn't that be cool if we could get, there are 1 million people who have VR headsets just from one company, just from HTC, and wouldn't it be amazing if we could get them all doing NASA astronomy with us? Stay tuned. I just want to highlight a couple of the other citizen scientists who held out with Disk Detective because I'm so proud of them. One of them is Hugo Durantini-Luca. He's, I've known him now for 7 years, no longer than I knew my first wife. Hugo is an amateur astronomer. Peter knows him quite well, and he lives in Cordoba, Argentina. And when he learned that we had interesting objects in South America, he took it upon himself to drive down to the nearby university and introduce us to some new professional colleagues who then helped us follow up those targets. And then later on, he drove across South America to help out with an actual observing ground. So here he is at the telescope helping us out. Michiharu Hugo is also an eager citizen scientist on the Disk Detector project, and he was so enthusiastic about the project, he started giving demonstration sessions to friends in Japan about the project. And professor from the University of Tokyo attended one of his demonstration sessions and invited him to apply for a job. And then he got the job, and now he's teaching college as a result at Massey University. So as I was saying, the project, the original version of Disk Detective, it shut down, but it's now been relaunched just this June, led by Steven Silverberg, my former graduate student. And he's reinvigorated the project by adding data from, let's see, I'll show you that in a second, by first using Gaia to pre-select the targets, and second, using data from SkyMapper, PanStars, and Unwise, all of which were unavailable when we launched the original project. So there's all kinds of new data built into the new version of Disk Detective, and we're hoping that we'll find some more of these record-breaking disks through this process. You'll see up in the upper right-hand corner, you can see my cursor here, the project has been translated now to 17 different languages. Sorry, not 17, 7 different languages, all by volunteers. So let me pause at this point and ask you all. I'm going to skip ahead because I really want this chance to pick everybody's brains. You've all heard, I think you heard Aaron speak about Backyard Worlds. I'm not sure I want to duplicate that. But I very much want to get your take on this. Can you all see my PowerPoint screen too, still?
It's still in the editing mode.
Okay. Well, I could equally well have just stated these questions, but here we are. Let's stare at them together. I'd like to know what NASA can do to help invite amateur astronomers to become citizen scientists, to work on these projects with us. And I'd also like to know, if we were to hold a virtual conference for amateur astronomers, what do you think of that? What should we do during the conference? And what would make you want to attend? And I wish I could see you all right now to call on you by name or ask you in person. Maybe I can ask.
Mark, if you want to finish the talk and then come back, and we'll have questions, and you can ask those questions of us, and we can ask questions of you. And we can then do that in gallery view.
Okay. Let's do that now, because this is very important to me. So I've already been talking at you for about 45 minutes. Should we do that?
Yeah, for me.
Great.
If you stop sharing your screen, Mark.
Okay.
Okay, and we go back to gallery view. I hope everybody can see gallery view now. Give me a wave if you can. Can you see gallery view? Yep, thank you very much. And so, Mark's questions. So, Mark, do you want to ask your first one?
Sure. What can we at NASA do so that we can take more advantage of the skills and the brain power of amateur astronomers to do science with us?
Okay, ladies and gentlemen, usual routine. If you can wave at me, or preferably put a blue hand up electronically. So if anybody's got anything to contribute, can you give me a quick wave on that question? Now it's got to be said, Mark, that we have been involved in British-based citizen science projects like Zooniverse and
Yes.
the Red Planet. So we're involved with that. And my first instinct would be to point you towards the BAA,
Yeah.
and the British Astronomical Association, and let them be the go-between, or even on a sort of a more a wider viewpoint, is that there is a gentleman, I think you might have come across him, Dr. Chris Linnott, who presents a very popular program called The Sky at Night. And he is also very, very keen on citizen science projects. So I would say that he would be your first port of call, how to get the British public and the British the British amateur astronomical public involved in more citizen science.
Super. So, so Chris Linnott, of course, is the founder of Zooniverse.
Yes.
And so we are very delighted that Zooniverse has recently, in the last 6 months, become a major NASA partner.
Right, okay.
So we are collaborating with Zooniverse. And in fact, Disc Detective, Backyard Worlds, Planet 9 are both hosted by Zooniverse. So we're lucky enough to have a strong connection with Zooniverse.
Oh, there you go. Problem solved already.
Yeah. Yes.
So, has anybody else got any suggestions or thoughts? Phil, can you unmute your microphone?
Yeah, thank you. Thank Mark for coming. I've got a couple of comments. One is the NASA webpage is really good. Perhaps you could make part of the NASA webpage a bit more interactive, where you can like ask questions or make suggestions via the internet. You can see lots of your space, your planetary stuff, your deep space stuff, but there's no interaction with the public on that. But the other thing, sorry?
Let's make sure I know which page you're talking about. Are you talking about science.nasa.gov/citizenscience?
Oh, I don't know if it is that one or not. I can't tell you.
Okay.
Yeah. So, but the other thing is, we were talking about this before you came on about radio astronomy. While we're practical astronomers, as in observing, we also do a bit of radio work as well. And we've just been talking about some of our members like to tune into the satellites flying around, and we've been doing some of the NOAA. In fact, Paul's built a NOAA aerial, and he's just started building a mast for the guards to get a better reception. But my point is, all the analog stuff is disappearing, and it's the same with the International Space Station. I followed Mir. What got me into radio and astronomy was the Mir Space Station, and how when it flew over, we could tune into it. I've listened to the space shuttle talk to Houston, flying over the UK. We've seen this fuel tank and the space shuttle fly over. We've tracked it, plotted it, predicted its passages and everything. We've picked up the radio frequencies, but they all seem to be stopping now, and it's extremely difficult to get any signals from anything. What I'm scared is it's all disappearing, and all those amateurs that have got basic stuff now can't, how can I put it, interact with what's happening. So there's lots of stuff on the internet, and everything's going digital on mobile phones and the computer, which is fantastic, getting pictures from space. But it's nice to be able to build your own equipment and download it onto your computer and process it yourself. But that's all disappearing. So if anything, I'd like to say to you is, can you take it back up the management tree and say, look, you know, these guys can't do this now because you're making it too difficult. See where I'm coming from?
Yeah. I wish I were able to go and clean up the radio sky single-handedly for you. But in the meantime, have you heard of Radio Jove?
Yes, I have. Yes, I've heard of it.
Okay. Do you participate?
I've not done it. I've not done that one yet, but it's something I've looked at.
So Radio Jove, the project is in the process of rebuilding its website. If you go to that page that I just put in chat, it looks kind of like it's a toy, but it's not. So you have to kind of dig deeper in here and get in touch with them. The trick is to go through kit ordering, or go through contacts and contact them by email. So there's a growing group of people the site looks like it's going to be educational, like it's going to be for schools, right? But the thing is that there's a growing group of observers now that have either built their own kits or worked with Radio Jove. They distribute kits or they sell them for reasonable fee. That are their radio telescopes. They're small radio telescopes, right? And they often work at decametric frequencies, and they help fill in gaps in radio astronomy coverage.
Yeah.
And they have some very promising data sets on the radioactivity of the sun, and some publications coming out about that work. So they're doing genuine science and gearing up for even bigger things to come.
Yeah, that's
So
what we'll look at.
it sounds like your people. So I want to make sure you heard about them.
Yeah. Well, I've heard Radio Joke. My radio gear doesn't go down to 21 centimeters, so that's one of the reasons why it stopped me doing it. So mine's like 25 up to 1.3 gigahertz. So I can do the normal radio stuff, but that's out of my range. But I'd have to buy a new radio to do that. But yeah. Well, you can build the aerials and receivers and stuff, can't you? Yeah, it could be a project we could do in the future.
Oh, that'd be wonderful. If I can be of help, putting you in touch with people, let me know.
That's good.
I've got to say that one of the things, one of the projects I have thoroughly enjoyed over the last 2 years is the JunoCam project on Juno. And the access to the raw data, or very raw data, and being able to take that and manipulate it yourself as an amateur has been a real pleasure. And I've thoroughly enjoyed using the data sets from JunoCam. And really, if we could have that sort of, more of that sort of level of access to data, that would be a great boon for amateurs and getting people into citizen science.
Let me tell you another project that I'm working on, since you brought up access to data. So I put a link to JunoCam in the web pages. That's certainly been a rewarding project. So I discovered these cyclones around the poles and so on. But you reminded me that one of my projects right now is to try to help NASA's data archives become more accessible and useful to the public. So, for example, have any of you tried directly accessing a NASA archive without going through a citizen science project?
Hands up, anybody? Gary Goldthorpe. Gary, can you turn on your mic, please, and just give us a rundown of what you were trying to do?
So I ended up looking at some of the Hubble data, some of the raw Hubble data, which was interesting to work with, to say the least. Trying to get all the data files out and all the flats and the darks, and then try and process it and get an image out. It was quite difficult, certainly at the time, because obviously that was probably at least 10 years ago when we were looking for that data. But it was satisfactory. But we couldn't get anywhere near like what the press release photos were, but they were good. And
fantastic.
The sheer quality of the data is much better than what we can do. But when you look at the raw image, you think, oh, that doesn't look very good. And then by the time you've processed it, it's much better, and you understand why you need to do things.
Oh yeah.
So, I also use the ESO data from the VLT.
So what was it like going through the archives? Are they user friendly?
From what I can remember, it wasn't very user friendly at all.
Not very user friendly.
You had to know what it was and what you were looking at. So, and it took a while sometimes to get all the right files down.
So it's a big nut to crack, but I'm trying to improve that. And one thing I'm starting with is just attacking the sheer onslaught of jargon that you get when you go to a NASA archive, right? There's acronyms that aren't expanded. You know, it's like go to the PDQR, and what is PDQR? It doesn't even tell you, right? And so, you know, if any of you are interested in helping me with this project, you know, just looking at a NASA page and looking at a NASA archive page, like here's a website. Tell me where the acronyms are. Yeah, tell me where not the acronyms. I can see those, but you know, tell me where the jargon is. Just like this is jargon, this is jargon, this is jargon. Here's maybe even suggest some definitions for it, and then I can go in and fix it. If any of you are available to help me work on that, please reach out to me because there's a lot to do. It's a big project.
Okay, we'll try and see what we can do. Gary wants to have another word.
Yeah, so I would say one of it's not an astronomy-related Zooniverse that I was involved in, but I was involved in one right at the beginning of the lockdown in the UK, which was about the UK rainfall figures, and they were asking people to effectively transcribe figures back from the 1850s, I think it was, all the way up to 1950, and there was a huge amount of people got involved in that, and I think a lot of that was about the publicity that it got. So it managed to hit the front pages of the BBC News, the British Broadcasting Corporation News website, and there were on some days there were hundreds of thousands of data points being input. So in a very short period of time, over maybe only a couple of weeks, they'd digitized a whole data set, and it was just getting the people motivated into doing things. Now, obviously, they dropped in at a very fortunate time when everybody was sent at home and they couldn't work. But I did a bit in an evening. But you'd look in sometimes, and you'd look at see when people had been doing it in the day, and there was a massive spike, from maybe 8 o'clock in the morning UK time down to about 5, 6 o'clock at night. And then there was another blip later on, obviously, when everybody's finished their tea and what have you, and dealt with whatever they need to be dealing with. But I think the thing I would take out of it is there was that publicity point that the BBC picked it up and ran with it, and it was just fortunate at the time when they were involved. But that publicity side is, you can publicise it quite easily to amateurs, and there may be 100,000 amateurs in the UK. But from a science point of view, or for actually looking at images, there were there was more than 100,000 people doing it at some times who were registered to do it. So getting into the people and getting that level of interest, especially if it's a short term, people will go in and do things for short term. And I presume what you'll see is, if you looked at a person's figures, unless they were particularly interested, you'll see initial spike and then they'll slowly drop away. Whereas keeping that either getting as much done in that very short period of time when they're interested, or actually maintaining that interest level.
Yeah, that brings me to the next question I wanted to ask, which was, speaking of maintaining interest levels, should we have an event? Should we have an online gathering?
I think a lot of people would immediately say yes, but once again, it's about generating and maintaining enthusiasm. And the longer you leave something, then the less likely of success. The other thing is that obviously is the time differences, and a truly international event, how successful can it be? I mean, it's difficult. It's now what? It's 9 o'clock in the evening here, and time-wise at yours, I presume it's about midday. It's about midday where you are.
4 o'clock for me.
Yeah, and the Australians haven't even got up as yet. So,
how do you never mind the Australians. I've given up on it.
Don't worry about them.
How you organise them, I'm not too sure. But yes, an international event. But how you break away from the big speakers who everybody wants to listen to every speaker, obviously, but the big draw speakers being put up by the hosts, and then breaking down into either national or groups of countries where they go off for smaller meetings to deal with ideas and viewpoints that are specific to them. That sort of organization. So
it sounds like you're suggesting that we should have some fancy big name speakers.
Oh, definitely.
Yes.
Definitely.
I mean, any come to mind in particular?
I think Mr. Penrose would be high on our list at the moment.
Okay, so our recent Nobel laureates. Yes.
Yeah, well, a recent British Nobel laureate, always good news. Yeah. Gary, you're muted.
I suppose the thing is you've got to get a good speaker for the area that you're interested in, because you can't say, well, we want to cover all the areas of the universe. You've almost got to concentrate in smaller areas and get somebody who was particularly specialist in that field to enthuse the people. Like I've seen, say, quite a few of the scientists. I travel all over the UK listening to speakers, and I've seen quite a lot of them. But you only tend to get the really big name speakers in like London and things like that. But I suppose to help with people being geographically and time different is almost like get them to record something to enthuse people, and then that can go out to everybody if they've got a local coordinator.
Okay, great. That's a great tip. So it will be exciting to hear. So it sounds like that would be a good draw to get people to come in. Would be some big names. Why not?
Yep. I've got a couple of questions for you, Mark. A little bit off topic, but let me see if I can read my notes. The economical efficiency of citizen science compared with, shall we call it, professional scientists.
You know what I call them? I'd say.
Is it worth putting the amount of effort that you obviously do put into it? Does it stack up economically?
Does it stack up economically? So I would say that if citizen science projects accomplished only what they set out to do, then it's about a wash. Because it takes a lot of effort to teach everybody how to do the project, right? To set up the website, to train people, to train moderators, to constantly be communicating on Twitter, on blogs, on newsletters. It's a lot of team communication work that my professional colleagues aren't used to, and they're not great at, and they're it's a lot of time to do that. So the thing is that look at all those examples where citizen science went farther than anyone ever dreamed, where people discovered we discovered stuff we didn't know to look for. Backyard World's Planet 9 supposed to be hunting for white dwarfs, but discovered the oldest white dwarf. Sorry, it's supposed to be hunting for brown dwarfs. It discovered the oldest white dwarf with a disk. Galaxy Zoo discovered the Vorverp phenomenon. Aurorasaurus discovered Steve. The whole Sungrazer project came into being, magically, right? All of the successes they aren't things that people plan. And when you take that into account, then it's not like I've counted up the dollars. Actually, I have counted up the the amount of time spent that people have contributed. But in terms of scientist time and research dollars, the big boon to the science comes from the serendipitous things, the things that scientists didn't plan. And yeah, that has been tremendous.
Right. Okay.
Most of the no long period planets. I mean, it's you know, we're talking about here, you know, making major shifts in a field. You know, you if you discover most of any kind of phenomenon, Backyard World's Planet 9 is they haven't discovered most of the white dwarfs, but most of the really cold ones. It's kind of a tie, as Peter will tell you, between two projects. I'd say they're Backyard World's Planet 9 versus Catwise are neck and neck in terms of discovering the most new cold brown dwarfs. So, you know, it's a major force.
Right. Okay. Yeah. I'm looking around. I shall ask people for questions again. Put a digital hand up if you can. If not, wave at me. And I'm not getting any waves at all. Not even... Oh, Michael Moxon. Can you turn on your microphone, Michael? I'm sorry about that, Michael. I changed the P for an M. Michael Poxon, have you got your question?
Yeah. Thank you, Mark. Basically, I run the YSO group at AVSO, so we're sort of naturally interested in things like circumstellar disks. Really, the question is, are you just looking for sort of normal planet-forming circumstellar disks, or are you also looking at things like debris disks?
Oh, sure. Did you send me an email, by the way? Somebody sent me an email about a variable star that I'm...
Yes,
thank you very much for that. Yeah, sadly, we don't have anyone on our team who's kind of a variable star specialist. You may be better plugged into that community through a VSO. The answer is yes. We are, in fact, originally set out 14 years ago. I set out to find debris disks, and then turned out that the protoplanetary disks were more scientifically fruitful. But the short answer is yes. Protoplanetary disks are more common.
Yeah.
So we have more at this point.
Yeah. Also, we produce a monthly e-newsletter, you know, on sort of subjects related to young stellar objects. I'm just wondering if you could write a little sort of mini article about disk detector for it.
Sure, I'll put that in my queue. Okay. You don't need it in any hurry, do you?
No, it comes out at the end of the month, and it doesn't have to be this month. So, yeah, sometime you can just reply via the email I sent, if you like. It's probably easier.
Okay, super. If you let me know the parameters.
Yeah, okay, that's super. Lovely, thank you.
God, these Norfolk folk are really cheeky, you know. So, I don't know.
That's how we like them.
So, it's no wonder we've got sentries on the Trent. Has anybody got any other questions? No, I can't see anybody, and I'm not getting anything up on my computer. Ladies and gentlemen, going once, going twice.
I'll have it.
Going 3 times. And Marc Kuchner, thank you very much for a very interesting talk. And ladies and gents, can we give our usual Mexborough and Swinton Astronomical Society thank you?
Yay.